Okay, now we are discussing about the Huckel's rule. Huckel's rule is used to explain the aromatic nature, aromatic, anti-aromatic, and anti-aromatic. Next one, non-aromatic nature are explained by Huckel's rule. So here we can explain these two. But here, if we know the benzene molecule, generally we know aromatic compound means here benzene is a major initial compound as a aromatic. The general formula of benzene is a C6H6. Okay, here aroma means what? Here it is pleasant smell. Okay, benzene is having pleasant smell. But some rules are introduced to explain the aromatic nature for any compound. Then first of all here aromatic. Aromatic here it is aromatic. Some conditions are given here it is aromatic. Next one anti-aromatic. Third one is a non-aromatic. Non-aromatic nature. Anti-aromatic, aromatic, non-aromatic. So here the all compounds which are in aromatic nature, they should be in cyclic form. The next one, second condition, the molecule should be in planar. Molecule should be in planar. Carbon should involve in sp2 hybridization. Third condition here, it should give the conjugative system. It should contain the conjugative system here. The next one here, fourth rule here, it should follow the 4n plus 2 pi number of electrons. 4n plus 2 number of pi electrons it should contain. The molecule which is following these conditions, that molecule is aromatic in nature. The next molecule which is following these conditions, one is the cyclic, one is here the planar, and planar. Next one here, planar molecule means here it is involves in sp2, but molecule should be in conjugative, completely conjugative system. The next one, molecule should follow the 4n number of pi electrons. Should contain 4n number of pi electrons here. The next one, molecule should be in cyclic. Okay. The next one, molecule is a non-planar molecule. Non-planar molecule. The next one, it is here non-conjugative, and next one, no rule to identify the electrons. That's why the molecule which is not following these two, aromatic and anti-aromatic, it's compulsory non-aromatic. Molecule either follow the aromatic or either follow the anti-aromatic. Both are not followed means here it compulsory non-aromatic only. That's why here if we take the example, benzene molecule. In this one, 3 pi bonds are present. 3 twos are 6 pi electrons are present here. 3 to the 6 here. 6 pi electrons are present. 6 pi electrons are present. But here apply these conditions. One is all carbons are present in which form here? Cyclic form. Then molecule is a planar molecule. Benzene is a planar molecule, we know. Next one, all pi bonds are present in which one here? Conjugative mechanism. All carbons are involved in sp2. But it is having how many number? Here observe 4n. Take that 4n plus 2, 4n plus 2 pi number of electron. Substitute n is equal to 1. So here n is an integer, does not give any information here. If we substitute n is equal to 1 in this one, 4 1s are 4 plus 2. 4 1s are 4 plus 2 means here how many electrons are there? Here it is 6 pi electrons are present here. That's why it is an aromatic compound. Suppose if we take the second one, naphthalene molecule. Naphthalene molecule means here what we can take here, the 2 benzene rings are present like this. How many pi bonds are present? Here it is 5 pi bonds are present. According to structure, 5 to the 10 pi electrons are present. But apply all the rules. All carbons are present in cyclic. Same, it is a planar molecule. It is a conjugative system. Conjugative system, observe. Alternative pi bonds are present. Then this is alternative, this is also negative, all are in alternative form. And also according to rule, if we substitute n is equal to 2, then 4 to the 8 plus 2, again what we are getting 10 pi electrons here. Okay, that's why here 10 pi electrons are present. The next one in this case here it is 3 benzene rings are present here. Then 3 benzene rings. And next one here, in this case, observe here, this molecule is an anthracene molecule. How many pi bonds are there? 7 pi bonds, 7 to the 14 pi electrons. All rules are applicable. Even n is equal to 3, if we substitute 4, 3, the 12 plus 2, then what we can get? 14 pi electrons, here it is. That's why here, in this case, 14 pi electron, 6 pi electron, so in the 10 pi electron, 14 pi electron, all rules are applicable for this one. That's why this is here aromatic in nature. This is also aromatic in nature. This is also aromatic in nature. Then, if we take the other example for this one here, the other example is, suppose here, this is a molecule. Then at this condition, it is a negative. Okay, pi bond and pi bond. Negative means what the meaning of that? Two electrons only. Observe, they are in conjugation. This pi bond and this lone pair is means negative conjugation. This pi bond and this negative is in conjugation. They are in conjugation. Then here, this molecule is a planar molecule. It is following the conjugative system, and it is a cyclic molecule. Then according to rule here, 4n plus 2 pi electrons here. 4n plus 2 pi electron means 4 to the 8 plus 2. Then here, but if we substitute 4 into 1, then 4 into 1 plus 2. Then what we got here? 6 pi electrons here. Means it is having the which one here? 6 pi electrons are present. And all rules are applicable. That's why it is here the aromatic molecule. The next one, suppose here we take cycloheptatrienyl cation. Cycloheptatrienyl. Cycloheptatrienyl cation here. Now this is here the molecule. In this one, hepta means here how many? 7 carbons are present. Then in this one, 3 pi bonds are present. One here, and one here. Then this is here the positive charge. Okay. Then observe here, positive charge and this pi bond are in conjugation. This positive charge and pi bond in conjugation, all are in conjugation. But here, how many pi bonds are there? 3 pi bond means here 6 pi electrons are present here. 3 pi bonds, 6 pi electrons are present. Then if I substitute 4 into 2, 4n plus 2 pi number of electrons here. 4 into 1 plus 2. 4 into 1 plus 2 means what is this one here? 4 into 1. Then again 6 pi electrons we are getting. That's why if we substitute n is equal to 1. Then here, but you will get the student will get a simple doubt. That is here what? How to identify a molecule is a planar. Generally, molecule is a planar means what? sp2 hybridization means what? Generally, planar only. Okay, that's why here hybridization is sp2, that molecule in a planar system. The next one here, conjugation. We can see the molecule as a conjugation, or we can see the which one here it is a cyclic. All are possible to see. Only planar that identified by which one? Hybridization. Then this is also which one here? Aromatic in nature. Suppose we are taking this molecule here. In this case, this is here the pi bond. Then at this position, which one here? Positive charge. It is a cyclic, it is a conjugation. But here, if according to this one, how many pi electrons are there? 2 pi electrons, 1 pi bond. Then in this case here, and you will get that out here, it is in this equation 4n plus 2 pi number of electrons here. Substitute n is equal to 0 in this equation. N is equal to 0 means what we can get? 4 into 2. 4 into 2 means here what we can get here? 4 into 0. N is equal to 0 means 4 into 0 plus 2. Then we can get 2 pi electrons only. Means it is also aromatic in nature. How they are? Pi bond and positive are in conjugation. But in the first example, see this one, you will get the negative out here. This negative and pi bond in conjugation. Negative means what? Electron pair. How it is here? Suppose this is moving this side, immediately can move this side here. Mean this carbon gets the which one here? Negative. That's why it can exhibit the resonance structures That's why this negative charge also identified as a pi bond. Mean this negative charge also involves in pi bond formation due to resonance structures. The next one, suppose here, if we take this example here, then in this one only pi bond is present. At this position, no charge. No charge means here no conjugation. No conjugation means here it is a non-aromatic. No conjugation is nothing but what here? Non-aromatic. Compulsory anti-aromatic, compulsory conjugation is needed, planar is needed, cyclic is needed, but 4 and pi electrons are needed here. That's why no conjugation, that's why it is a non-aromatic. Suppose here if we take this molecule. Now in this one, two pi bonds are present. Both are in conjugation. All are in sp2. That's why it is a planar molecule. And a planar molecule, both are in conjugation. Then here it is the sp2 hybridization. That's why what we can take here. Suppose 4 and pi electrons rule it is followed. How it is substitute n is equal to here 1. N is equal to 1 means what we can get here 4 pi electrons are possible. That's why here 2 plus 2, here 4 pi electrons are possible for this one. So this is here the which one? The 4 pi electrons. Then it is following all rules. That's why it is nothing but what? Anti-aromatic molecule. So like this here we can take. Suppose here if we take at this position here, that position is here. Same here at this position in the last example, what we told in the last example, negative we wrote here. Suppose at this position positive. Then observe here, these pi bonds are in conjugation with the positive charge. When they are in conjugation with positive charge, but how many pi bonds are there? Two pi bonds. We are not considering this positive because positive means not electrons. That's why here 4 pi electrons are present. Again, which one? N is equal to 1. Following which rule here it is? Anti-aromatic rule here. Anti-aromatic rule. But if you take other example for this one, suppose here it is, in this one, two pi bonds are present, no charge is present at this position. No charge is present means what we can get here it is, no charge means no conjugation. No conjugation means no planar. How it is not a planar? This carbon is a sp3 carbon. That's why it is not a planar molecule. That's why not a planar, not a conjugation. That's why what we can write here, this is non-aromatic compound. Like this here, we can write suppose here this example also. So in this example, in the last example, cycloheptatrienyl cation, at this position we wrote the positive. At this position we wrote the positive. Same example, but it did not wrote the positive here it is. Then this is which carbon? sp3 carbon. sp3 carbon means here it is. I think we understood here it is not a planar. Not a planar means not a conjugation, not a planar, but only cyclic. That's why not following any rule. That's why what we can say it is here non-aromatic compound. So finally, initially what we told the three conditions here, three steps here, aromatic, non-aromatic, anti-aromatic. For each one we give the four rules. The molecule which is following those rules, we can say aromatic, non-aromatic and anti-aromatic molecule here. So this is here the aromatic nature for the benzene molecule here, and benzene and other compounds also. Why we take the benzene here? Benzene is a basic compound we told here. This is here the aromatic and non-aromatic nature. The next one, we are discussing about the here structural information of the benzene. Structure of the benzene molecule. How the structure of a benzene is explained. The structure of benzene is explained here. Generally, we know the molecular formula of the benzene is C6H6. Then in this case here, C6H6 is taken, but each carbon involves in sp2 hybridization. Each carbon involves in sp2 hybridization. sp2 means what here it is? Producing 3 sp2 hybrid orbitals. 3 sp2 hybrid orbitals. We know this molecule. This is here the benzene molecule. Then what we told, this is a pi bond, this is a pi bond, this is a pi bond. All carbons involving in sp2, sp2, sp2. Suppose here, this is a one carbon producing 3 sp2 hybrid orbitals. 3 sp2 hybrid orbitals here.
Okay, then here again second carbon, suppose it is also producing 3sp2 hybrid orbitals here, then at this position 3. The next one, third carbon here, it is also producing 3sp2 hybrid orbitals. Okay, then next one here, then this carbon here, this is a one carbon completed, second carbon completed, third carbon completed, then fourth carbon here, it is giving the 3sp2 hybrid orbitals. Again here it is giving the like this here. Then finally, what we understood here, it is 1, 2, 3, and 4 are completed. This is here the 5, and here it is. This is one is the fifth carbon is giving which one here 3sp2 hybrid orbitals here. Now this is here the last one 6 here sixth carbon at this position 3sp2. So finally, what we can get here, it is the sp2 sp2. So here this is a one carbon giving the bonds like this. This is here. It is a hydrogen. This is a one carbon like this here hydrogen. This is a carbon like this here. All carbons are giving single bond with the hydrogen, hydrogen, hydrogen. But at each carbon, what is there here? It is one unhybridized orbital is present. One unhybridized orbital. How it is here? Carbon valence configuration is 2s1, 2px1, 2py1, 2pz0 is a configuration. So in this condition, involves in which hybridization here it is? That is here the 2pz1, sir. 2pz1. Then in this condition involves in sp2 hybridization here. Then at each carbon, one hybrid orbital, which one 2pz1 orbital is there, which is having one electron here. These two overlaps here, and then at this also here, these two overlap, these two overlap. That's why we can get a double bond character between carbon and carbon. This is here. But in this one, generally carbon-carbon single bond length. Carbon-carbon single bond length is here. Generally, we can guess here it is 1.54 angstroms. Carbon-carbon double bond length is a 1.34 angstroms. But in this one, all bond lengths are same. That's why all carbon-carbon bond lengths are same here. In benzene here, same. When they are the same here, what is the bond length here? It is 1.39 angstroms here. 1.39 angstrom. Why they are the bond lengths are same? Because here in benzene molecule, resonance structures are the possible here. Resonance structures. This is pi bond, and pi bond here. So how they are here? It is this bond is moving this side, this bond is moving this side, this bond is moving this side here. This is pi bond, and pi bond. Then observe the meaning of this one here. These two are which one here? Resonance structures here. Resonance structures here. Then in this case here, due to resonance structures only, all bond lengths becomes equal. That's why the bond length of this one is 1.39 angstroms here. So totally in this one here, each carbon is giving 3 sp2. 6 carbons are there. 6, which one here? 18 hybrid orbitals are present in total benzene. And next one, unhybrid orbitals here. Each carbon is having one unhybrid orbital. It is a 6, and totally 6 hydrogens are there. That's why it is here. Number of unhybrid orbitals are 12. Each hydrogen is having one. That's why here this is how we can say this is each one is again overlapping with hydrogen. Each one is again overlapping with hydrogen. That's why we can get like this here it is. Okay, then we can guess here this is here the structure. But in this case here, totally number of hybrid orbitals is 18. Number of unhybridized orbital is here the 12 in benzene. This is here the structure of the benzene molecule.